So today I want to talk to you about intraocular lens dysphotopsia. And you might be saying, why is that neuro-op? Well, first of all, it's not, but it comes to neuro-op. And the reason it comes to neuro-op is it's mistaken for neuro-ophthalmic disease. The stem is usually that they have the symptom only after cataract extraction and intraocular lens placement. And so it comes in two flavors, a negative version and a positive version. And so these photopsias are dysphotopsias because they're induced by the intraocular lens and they're disturbing to the patient. And so you need to know a little bit about the intraocular lens, but I'm not going to go through ray tracing and all the diagrams. You can look all that up yourself, and it really has no bearing on neuro-op. But just to give you an idea of what the problem is, so when we have this lens in the eye, the light can hit the edge right here. And depending on the edge design, square or rounded, it may or may not produce a problem with the light hitting it because it can project onto the retina. And so if it projects onto the retina and casts a negative impression, it'll make a temporal scotoma. And it can look like this crescent. And the reason that comes to neuro-op is it can mimic a real finding called a monocular temporal crescent. And you can watch the video on the monocular temporal crescent. So it's monocular, it's temporal, it's a crescent, and it's negative. And so that's going to sound very much like the temporal crescent syndrome. And so just to remind you of what the temporal crescent is, as you know, the two visual fields are not circles, they're actually ovals. And this part of your field here is monocular because it has no overlap. This has no correlate in the nasal field. So the nasal field and the temporal field are not the same size. The temporal field is bigger by this monocular temporal crescent. And so if you're looking out, your field is binocular between here and here, but this portion of your field is monocular. And so a patient who complains of this negative dysphotopsia might sound to you like a monocular temporal crescent when it's actually the intraocular lens. The positive version of it is the same problem. The light ray hits, it hits the retina, but because of internal reflectivity, it generates a light. And so the most common complaints are glare, starbursts around headlights. It's usually worse at night. And then sometimes people see a line. And so they might complain of this flashing white light or crescent, again, monocular and temporal, but it'll be positive phenomenon. So both the positive and the negative photodysphotopsia can come to neuro-op. The positive one can be misinterpreted as migraine. However, in migraine, as you know, migraine is bilateral in the aura, and it's a jagged line, and it's usually not induced by lightning conditions. So the key and differentiating features for both the negative and the positive dysphotopsia that differentiate it from neuro-op things, TIA, migraine, or the monocular temporal crescent from a stroke, are it's intermittent, it changes with the lighting conditions, it's associated with glare, starburst, and it's in this temporal portion of your field, and it occurs after cataract extraction with intraocular lens placement. I won't go into the treatments, but you can try and change the pupil size by giving pilocarpine, or you can do the surgical exchange of the lens, or do a piggyback plano lens. I defer all that to the cataract surgeons. The main thing you need to know in neuro-op is the intraocular lens dysphotopsia, negative and positive, can mimic the monocular temporal crescent, migraine, TIA, or stroke, and you need to be able to identify the key portions of the stem, intermittent, different symptoms based on lighting conditions, and occurred after cataract extraction with intraocular lens placement.